Analyses of facial thermal patterns can reveal certain diseases. Temperature changes in various areas of the face may signal certain diseases. An artificial intelligence program developed by Chinese researchers, trained to recognize facial thermal patterns, is able to recognize diabetes or hypertension. It can also show the rate of aging. The method developed by scientists from Peking University requires a thermal imaging camera and specially trained algorithms that, by comparing the heat of individual parts of the face, can help diagnose various ailments. The method is still under development, but in the future it may be a simple and non-invasive approach to the early detection of certain diseases. The description and results of the work of Beijing researchers were published in the journal Cell Metabolism. Facial temperature is not the same in all areas. The nose may be warmer than the cheeks. These differences are small and difficult to feel by touch. But artificial intelligence algorithms with access to a thermal imaging camera can handle this task perfectly. Scientists in Beijing trained algorithms to recognize specific facial thermal patterns. They obtained and analyzed facial temperatures from 2,811 participants aged 21 to 88. Their goal was to train their artificial intelligence model to predict a person's thermal age. Although it is known that human body temperature decreases with age, how facial temperature changes over time remains largely unknown. In their work, researchers identified several key areas of the face whose temperatures were significantly associated with age and health, including the nose, eyes, and cheeks. The researchers found that the temperature of the nose drops with age at a faster rate than other parts of the face, suggesting that people with warmer noses are younger. The opposite is true for the temperatures around the eyes, which tend to increase with age. In further research, it was found that people with metabolic disorders, such as diabetes and fatty liver disease, tended to have higher temperatures around the eyes than their healthy counterparts of the same age. Their facial thermal profile suggested that they were older than their age. In turn, people with elevated blood pressure had higher cheek temperatures. In addition, men with hypertension tended to have relatively cooler noses. By analyzing participants' blood samples, they found that the increase in temperature around the eyes and cheeks was mainly due to an increase in cellular activity related to inflammation, such as repairing damaged DNA and fighting infection. This led to an increase in temperature. The machine learning model developed in the study was able to automatically process and analyze a heat map of a person's face and predict whether they had a metabolic disorder, such as fatty liver disease or diabetes, with more than 80% accuracy. Continuing the study, the researchers asked 23 participants from the previous group to jump rope at least 800 times a day for 2 weeks. They wanted to check whether exercise could affect the thermal profile of the face. To the team's surprise, these participants reduced their thermal age by 5 years after just 2 weeks of exercise. The researchers now want to see if their method can be used to diagnose other diseases, such as sleep disorders or cardiovascular problems. They argue that thermal imaging of the face has significant potential in the early diagnosis of some diseases. Nanorobots capable of killing cancer cells. Promising results of tests on mice. Swedish researchers have developed nanorobots capable of eliminating cancer cells. For this they use a special weapon hidden in their nanostructure, which is activated only in the acidic microenvironment of the tumor, thus protecting healthy cells. Tests on mice showed promising results. Nanorobots may be more precise and more effective in the fight against cancer than some drugs or other types of therapies. Microscopic robots developed by scientists from Karolinska Institutet can effectively kill cancer cells. Their weapon is a nanostructure previously developed by the same team of scientists, consisting of 6 peptides arranged in a hexagonal pattern. Contact of the nanostructure with the cell surface causes cell death, so to prevent the nanorobots from attacking all the body's cells, the weapon is activated in a low pH environment that usually surrounds the tumor. The study was published in the journal Nature Nanotechnology. The hexagonal peptide nanopattern becomes a lethal weapon, explains Professor Bjorn Hagberg from Karolinska Institutet, who led the study. If it were given as a drug, it would start randomly killing cells in the body, which wouldn't be good. To circumvent this problem, we hid the weapon inside a nanostructure made of DNA, he adds. The art of building nanostructures using DNA as a building material is called DNA origami. Hagberg's team has been working on such structures for years. Now they have used this technique to create a kill switch that is activated under the right conditions. We managed to conceal the weapon in such a way that it can only be exposed in the environment in and around the solid tumor. This means that we have created a type of nanorobot that can target and kill cancer cells, Hagberg emphasizes. The developed structures have a diameter of only 10 nanometers. They act on receptors that line the membranes of all our cells, called death receptors. When activated, they cause cell death. The key is low pH. This type of acidic microenvironment typically surrounds cancer cells, which activates the nanorobot's weapons. The developed peptide weapon activates when the pH drops to 6.5. At normal pH around 7.4, the hexagonal peptide nanopattern remains hidden inside the nanostructure. Researchers tested their nanorobots on mice with breast cancer. Injecting rodents with nanorobots resulted in a 70% reduction in tumor growth compared to mice given an inactive version of the nanorobots. We now need to investigate whether this works in more advanced cancer models that more closely resemble the real disease in humans, says first author Yang Wang. We also need to find out what side effects this method has before it can be tested on humans, he adds. The researchers also plan to investigate whether it is possible to make the nanorobot more targeted by placing proteins or peptides on its surface that specifically bind to certain types of cancer.